Alright, let's look at writing chemical equations. So a couple keys, and this is reviewing, it's building on previous material. So a couple things we need to be able to do that you have already done in the course. Convert chemical names to chemical formulas, right? So we use our periodic table, we determine charges. We've got this nomenclature chart that has charges of many different ions on it. Also some common acid names will help us. So we need to correctly write the chemical formulas first of all, and then we're going to balance the chemical equation. So all of which we've done previously in the class. This lesson is just kind of putting it together, and so we get to combine them. Let me also point out something that this lesson does bring out. Some elements exist as molecules. There's only 7 of them that are like this. We call these the diatomics: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine all exist. So oxygen gas is O2, for example. So a few elements do exist like that, so that's worth knowing. So keep your nomenclature chart handy, keep your periodic table handy as we go through this, and of course both of those resources you should use will be available for you on the final as well. Let's look at a few examples from the lesson. Barium hydroxide reacts with carbon dioxide to form barium carbonate and water. So I've put a couple resources here on the slide. So first of all, let's write the chemical formula for barium hydroxide. So barium hydroxide, let me come down here. So barium, we would go to our periodic table and find it, and it's right here, second column, Ba. And what's its charge? Well, second column, but it also has a 2 right here. It is a +2. It loses 2 valence electrons. Hydroxide, that's a polyatomic ion. It's on our chart, and I don't expect you to have these memorized or anything. Just use the chart, know how to find it. And it has a -1 charge. So remember, these are going to form a neutral compound. So circle the charge there, cross and drop. So that would be BaOH2, and I put the OH in parentheses there, not because if I just write it after the H, it looks like 2 H's, but I need 2 hydroxides, okay? Now, how about carbon dioxide? Well, that's a molecular compound. They're just sharing. The di tells you how many oxygens there are, and that's one you're probably familiar with anyway. That's just CO2. So far we've got those. Barium carbonate. So let's do this again. So barium, still +2. Carbonate, again I wrote here from our chart, CO3 with a 2-. Oh, notice their charges, same number, just opposite charge. So they'll get together nicely, 1-to-1 ratio, BaCO3. And of course water, we should be very familiar with, H2O. So let's put these together. So barium hydroxide is BaOH2 plus carbon dioxide, CO2, reacts to form barium carbonate and water. And now we want to balance these. Let me change colors. Remember, when we balance chemical equations, we want the same number of each atom on each side. So we've got our reactants here on the left, products here on the right side. So let's kind of go through and see what we've got. So one barium looks okay there. 1 carbon, 1 carbon. Let's count up here. So 2 oxygens plus 2, that's 4. 3 plus 1, that's 4. 2 hydrogen, 2 hydrogen. So that was kind of convenient. It is already balanced. So writing the correct chemical formulas, here we have a balanced chemical reaction. Let's look at another one. Sodium metal, so that's just Na, if you go to your periodic table, reacts with water, so H2O, to form hydrogen gas. That's one of those diatomics. That's going to be H2 and sodium hydroxide. So sodium, again, go to your periodic table. It's in the first column, +1. Hydroxide I put on here for us from our chart. It's a -1. So that would get together nicely, NaOH. And now we just want to balance our equation, okay? So let's check it. Sodium, okay for now. 2 hydrogen. Notice over here though I have 3 hydrogen. So I need to get a nice multiple of 2. Let's put a 2 here in front of NaOH. So that'd be 2 hydrogens plus 2 would be 2. Give me a 2 there. Now 2 oxygens balance 2 oxygens. Also I have 2 sodiums, so one last step. I'm going to add 2 sodiums. Make sure everything's balanced. I really encourage you to balance equations with a pencil because sometimes we do need to go back and change those. Okay, how about this one? Aluminum and phosphoric acid. So aluminum and phosphoric acid. So aluminum, phosphoric acid is on our chart, so we can just write it right from there. React to produce hydrogen gas, so there's that H2 again, and aluminum phosphate. So aluminum, if you go to your periodic table, third column, it's a +3, and then phosphates right here from our chart. Notice they're going to be a 1-to-1 again, so AlPO4. Okay, let's balance it. So aluminum, aluminum, PO4, PO4. So it looks like hydrogen's the only thing that's off, doesn't it? So let's need a common multiple between 3 and 2. How about 6? So 3 of those, 2 of those. Then I would need a 2 here to balance my phosphates, and a 2 in front of my aluminum as well. Again, I know I'm balancing that kind of quickly, but we've had previous lesson on balancing where you've been able to practice that, so hopefully that's not too bad. Okay, one more real quick. Pentane. Notice they gave us the formula for that because we're not expected to just know what that is at this point. Burns in oxygen, so oxygen gas, O2, to produce carbon dioxide and water. Okay, so we got our chemical equation. Now let's balance it. Well, let's see what we've got. So 5 carbons here, 5 carbons. Let's try a 5 right here. See what's going to happen. And we're going to need 6 hydrogens, or I'm sorry, 6 times 2, right, to make 12, to balance my 12 here. Now let's look at our oxygen. See how many we've got? I've got 5 times 2 is 10, plus 6, so that's 16. And so let's throw an 8 right there. Hey, we've got a nice balanced equation. So I hope that helps. Again, most of this previous knowledge, just need to go back, use your chart, use your periodic table. We're in business.